Hello, in this video we're looking at how do we graph the reciprocal trig functions. So that means we're going to graph cosecant and secant and cotangent. So the first thing that we're going to look at is how do we graph cosecant x. And the best way to think about this is to remember that cosecant x is just 1 over sine x. So here what I have graphed is just one period of sine x. And I need to remember that cosecant is the reciprocal of sine x, because any time that sine is equal to 0, well, 1 over 0 will cause a vertical asymptote. So at all of these x-intercepts, now I have vertical asymptotes. And because this is a reciprocal, wherever sine has a maximum, the reciprocal will have a minimum. So what I'm going to do here is I'm going to note its maximum, and this will be the minimum of cosecant, so it's going to rise to each side to meet these vertical asymptotes. Likewise, wherever sine has a minimum, the reciprocal will have a maximum. So this is going to have a max at 3 pi over 2 negative 1. And this is a graph of cosecant. So if we were to list out a series of steps, it would be to graph the sine, make vertical asymptotes at the x-intercepts, and then make u-shapes at the max and min points. And we can graph one period of the secant function, which is just the reciprocal of cosine, in the exact same way. At the x-intercepts, I draw vertical asymptotes. I mark the max and min points. And these are going to be the minimums and the maximums of secant. All right, so let's try an example. Here we have y equals 4 cosecant pi over 2 x plus 3 pi minus 2. First thing I want to do is factor out this b to give me 4 cosecant pi over 2 times x plus 6 minus 2. And now I'm able to list out all the key information as if this was just the sine function. Such as this function has an amplitude of 4, we can find the period, which would be 4, we know the increments, the phase shift, and the midline. So now we're ready to graph this. And the first thing I'm going to graph is my midline at negative 2. Next, since this amplitude is 4, I know it's going to go up to 2 and down to negative 6. Its phase shift is left 6, so I'm going to start at negative 6. And it's going to have a period of 4, so I know it ends at negative 2. And the increments are nice and easy at 1. So now I'm ready to graph this as if it was a sine function. All right, so sorry I have to move some things around, but anywhere where I'm going to hit this midline, this acts as if it's the x-axis. So I'm going to draw my vertical asymptotes there. And at the maximum and minimums, I'm just going to draw my u-shapes. And there I've got my cosecant function. All right, for another example, see if you can graph negative 2 secant of 3x minus 6 pi plus 1. Just graph it as if it's a cosine function, and then apply the rules that we just learned. So pause the video, and in a second you'll see my work. And so hopefully you were able to factor out the b and find all of this key information. And now I'm going to go ahead and graph this function. So here I have my axes set up with a midline at 1, the amplitude is 2, and if you're wondering where these numbers come from, I started at 2 pi, and I'm just adding in increments of pi over 6. So like 12 pi over 6, 13 pi over 6, 14 pi over 6, so on. All right, so if this was a negative cosine function, we'd have a point here, 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 and here. Again, just draw your vertical asymptotes at wherever it hits the midline, and this will be the secant function. Now, these ones on the outside, these actually do complete the u's, but because we can't see the vertical asymptotes, it's okay just to leave them like that. And finally, we're going to look at graphing cotangent x, which is the reciprocal of tan. Now, the cotangent graph may seem more confusing as far as like where it comes from, but if you break it down to just a few simple rules, it's actually really easy to graph. Again, wherever you have an x-intercept for tan, the cotangent will have an asymptote. And just the other way around, wherever tan has an asymptote, cotangent is going to have an x-intercept. So let's take a second and think about where these points are coming from. from the unit circle, this 0 comes from whenever the tan is 0 over 1. So the cotangent would be 1 over 0, making an asymptote. This asymptote comes from whenever tangent is 1 over 0, so the cotangent would be 0 over 1. Now, at this point right here, this comes from root 2 over 2 divided by root 2 over 2, giving me 1. Well, the cotangent would just be that same thing flipped around, so they actually share this point. And from here on out, everything else works exactly like tan. The period is still pi. The next point is going to be right in between these 2 points at -1. And so the cotangent graph, whenever cotangent is positive, it actually decreases. So some important things here is the period still is just pi over b. The parent function has a domain from 0 to pi, and if we have a positive a, we're decreasing, and a negative a will increase. So let's do an example. Let's look at y equals -3 cotangent of 2 over 3x. The first thing that we can notice is that a is equal to -3. So we know that this is going to be an increasing function. So I'm going to go ahead and set up my graph to have a top point at 3 and a bottom at -3. Next thing I'm going to do is find the period, which is pi over b, so pi over 2/3, which is going to be 3 pi over 2. So unlike tan, where I have to figure out like this plus this is 3 pi over 2, cotangent's much nicer. I'm just going to end at 3 pi over 2. And at that last point, I'm going to have a vertical asymptote, just like I will on the y-axis. I can find my increments just by dividing 3 pi over 2 divided by 4. Or I can just think, okay, half of 3 pi over 2 is 3 pi over 4. And half of that would be 3 pi over 8. So the increments are 3 pi over 8, 3 pi over 8, 6 pi over 8, then 9 pi over 8, followed by 12 pi over 8, which reduces to 3 pi over 2. All right, at this middle point, I'm just going to hit the x-axis, and then because it was a negative cotangent, it's an increasing function, so I plot here and 9 pi over 8, 3, and just increase through these points. And that's one period of cotan. All right, and that's how we graph the reciprocal functions. Goodbye. Goodbye, 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 goodbye. Goodbye.